Michio Kaku, one of the most famous physicists working today, has talked about his thoughts on this topic. Kaku, who is famous for making amazing contributions to physics, recently said that the James Webb Space Telescope has found 6 huge, amazing systems that scientists used to think couldn't exist. If these assessments are correct, they might help us see the universe from different angles. Because of this, it is fascinating and worth keeping an eye out for these changes. As a physicist with both American and Japanese roots, Kaku is a unique person in the field of science. People think he knows a lot about both quantum mechanics and standard exploratory physics. While some researchers are more cautious and skeptical, Kaku is not one of them. He has been open to the amazing new discoveries made by the James Webb Space Telescope project. We are glad that this well-known researcher has chosen to speak out about what can no longer be said in private. When the famous scientist talked about what the James Webb Space Telescope had found, it was clear how excited and enthusiastic he was. Since this is what interested him in the first place, let's talk about what Michio Kaku's revelation of these 6 huge, unimaginable systems means. Kaku has always been able to think about new ideas because he is a researcher. He knows that Einstein's theories of relativity and Newton's laws are not enough to explain everything that is going on in the world. It's clear to Kaku that the new telescope's findings could possibly make science better, but many of his colleagues haven't been able to agree. Both supporters and opponents of quantum physics are worried and antsy about it, but Kaku can't help but laugh about it. The JWST has found 6 very large universes that date back to the very beginning of the universe. Even though they were only made a short time after the Big Bang, each of these grand systems has more stars than our own. The cosmologists who found these beautiful systems have named them universe breakers because their appearance would change everything we know about the universe. The idea of the Big Bang says that the universe was a disaster zone after the first event, but something about this doesn't make sense. It took hundreds of millions of years for the first solid objects to form, and it took even longer for things to reach a useful density and start giving off light. It should have happened a lot later for complicated structures like galaxies to start to form. Some of the newly discovered systems were bigger than the Milky Way, and the fact that they were so bright means that they were probably making a lot of new stars every year, while our galaxy only makes stars sometimes. It is still not clear when the first galaxies formed. Scientists haven't been able to figure this out until lately. One thing that is certain is that at first, there may have only been one or a few stars. Over time, these stars may have joined together to form bigger structures, which led to the formation of dwarf galaxies, which then merged and changed over time, just as previous theories said they would. At that time, galaxies that are incredibly huge and large could not have existed. This makes us wonder if the universe is much older than we thought, or if complex toroidal structures formed much earlier than we thought. Normal science is having a hard time with this situation because they are still having trouble with this model. Also, some areas of physics have strongly rejected this finding, saying that the calculations used to figure out the age might have been wrong. Kaku knew this and said, "There are many examples of old and wrong theories that keep being taught because some researchers are well known. The false ideas in many of these theories were finally shown to be wrong by basic research. So, the most important work in any study, but especially in physics, is done by the experimentalists who make sure the research is done correctly." To be honest, here on Earth we don't know very much about how the universe came to be. Based on observations of the expanding universe, the Big Bang idea was made in 1927. This made them think that the universe started out as a single point and has been growing ever since. People and scientists found it hard to picture a universe with a start and an end at the time. No one could have imagined a world that had always been there and had no end to time. Scientists are still having a hard time understanding it, but it's important to think again about these options. These new findings don't fit at all with what scientists have been using to support the Big Bang theory for years. But science has shown over and over that reevaluating and being open to new, radical ideas are important parts of the scientific method, just as important as proving certain theories and observations. When Einstein was young, people thought that the planets and stars were fixed in place in the world and that they took up a certain amount of space. We now know, though, that everything in the world is moving. Planets move around stars, stars move at different speeds within their own galaxies, and galaxies as a whole move quickly through the universe, and we still don't know what will happen to them. Scientists today have to deal with difficult results, and everyone knows that theories are not just assumptions or basic truths until they are fully tested or confirmed by accurate observations. It was proven that galaxies are moving away from each other, and this distance is measured in terms of how far away they are from Earth. This led to the idea of the Big Bang. This finding, called Hubble's law, showed that the universe has been growing for a very long time. This theory seemed to be supported by things like the cosmic microwave background radiation and the redshift of light from galaxies and other objects in the universe that are very far away. But it's important to remember that people in the past who thought the Earth was flat and the sun went around it also had proof like this until events or new technologies made things clearer and more accurate. We're seeing a similar thing happen right now. Scientists were hoping that the new JWST would prove what they already thought about the Big Bang. Instead, it has found 6 systems that are much more advanced than their years. This makes us think about how science is always changing and how scientists need to be open to new discoveries and rethink old theories based on new facts. Redshift is a tool that researchers use to find specific data in the study of the universe. The color of light changes as the light source and the viewer move away from each other. This is called redshift, which is also called the Doppler effect. To get this, picture yourself stopping and listening to a car coming toward you. You can hear the engine getting louder as the car gets closer, but the sound changes as the car moves away. This is because as the car moves, the sound changes. Light works the same way. When a light source, like a star far away, moves toward us, the light we see changes to blue tones. Moving the light source away from us, on the other hand, makes the light more red. The name for this effect is redshift. Redshift values have been turned into speeds and distances so that physicists can use them to figure out sums in their study of the world. It is important to keep in mind, though, that even small mistakes in these numbers can have big effects. The old ways of measuring are being looked at again, and the results that scientists will find about the newest discoveries about our world are very interesting. It is important to think about whether these results are really due to redshift mistakes, or if some experts are just denying the facts. This is a question that needs a lot of research and close examination of the study's data and methods. As science moves forward, instruments like the James Webb Space Telescope often make us question what we thought we knew about the world. This is shown by the recent discovery of 6 huge, unimaginable systems that date back to the beginning of the world. These systems don't fit with the usual ideas about how galaxies form, which brings up important questions about the time frame and processes involved in the growth of big structures. As a substitute for the Hubble Space Telescope, the James Webb Space Telescope is packed with cutting-edge technologies that let it see more clearly into space. Space experts can look into the past by using its ability to pick up light from very far away in the universe. This lets them study galaxies that formed billions of years ago. The finding of these very old and massive galaxies goes against current theories, which say that these kinds of big structures should have formed much later in the history of the universe. These findings have implications beyond astronomy and into basic physics. They are forcing scientists to rethink established theories about the early universe, such as the hypothesis of the universe's beginning, which says that the universe started from a single point and has been expanding ever since. At first, observations like the cosmic microwave background radiation and the redshift of faraway galaxies seem to support this theory. However, the finding of galaxies that look much more evolved than their age makes this story more difficult to follow. A famous scientist named Michio Kaku has said something about these changes. Kaku is known for his work in both theoretical physics and popular science. Kaku, who is famous for being able to explain complicated scientific ideas in simple terms for laypeople, sees the huge promise in the JWST discoveries. Unlike some of his colleagues who are more skeptical, Kaku believes that breakthrough discoveries should lead to changes in the way scientists think. As he has pointed out, empirical evidence is very important for shaping our understanding of the world. Theories must always change to include new information. The fact that these findings have led to debate shows how dynamic scientific inquiry is. On the one hand, supporters say that the finding of early massive galaxies suggests that the universe has been expanding for a longer time than was thought before. The usual belief is that galaxies change slowly over billions of years by merging and smaller things slowly getting bigger. This view disagrees with that. Skeptics, on the other hand, say that you shouldn't throw out well-known models just because you have a few observations. They want people to be careful and say that the unexpected results could be due to problems with how the data was interpreted or mistakes in the measurements. Redshift, a property of light from faraway galaxies that can be seen, is very important to these important studies. The light that galaxies give off changes as they move away from Earth. This moving toward longer bands is called redshift. Astronomers can figure out how far away a galaxy is from Earth and how fast it is moving compared to our own galaxy by measuring the amount of redshift in its spectrum. This knowledge is very important for making models of how galaxies change over time and for figuring out where galaxies are located in the universe. The James Webb Space Telescope can see faint infrared signals, which lets it look at galaxies that would normally be hidden by dust and gas in the early universe. This ability is very important for understanding how stars and galaxies formed in the early universe during a time called the cosmic dawn. By looking at the light that these faraway galaxies give off, scientists can figure out what chemicals were in the early universe and how the first stars and galaxies came to be. Finding these early massive galaxies has psychological implications beyond its astronomical ones. It makes us think about how science progresses and how people understand the world. As new findings and observations have been made, scientific paradigms have changed over time. Once thought to be impossible or too speculative to be theories, they are finally accepted as new evidence comes in. This process of theory, observation, and revision that happens over and over again is important for progress in all science fields. Philosopher Thomas Kuhn came up with the idea of a paradigm shift, which shows how drastically things change when problems with current theories lead to a major reevaluation of scientific principles. Cosmologists need to rethink how they think the universe evolved and how the galaxies we see today came to be after finding early huge galaxies. It shows how important it is to stay open to new, radical ideas and to change views based on results from experiments. Astronomers and cosmologists are also trying to figure out what these new findings mean for how we understand dark matter and dark energy. These hard-to-find parts, which together make up a big part of the universe's mass and energy, are very important for creating the structure of the universe on a large scale. The gravitational pull of dark matter affects where galaxies are found and how fast the universe is expanding. Dark energy is thought to be what makes the expansion speed up. The finding of early massive galaxies puts new limits on theoretical models of dark matter and dark energy. This makes researchers want to learn more about these strange things. In theoretical physics, the finding of early massive galaxies has made people interested in different models of the universe once again. There are some theorists who think that the observed strange events could be explained by adding more dimensions to the normal cosmological model or changing the laws of gravity. These theoretical ideas push physicists to find new ways to study the subject and come up with new theoretical models that can work with both existing observations and new data. The JWST's findings also have real-world effects on future space travel and the creation of more advanced astronomical instruments. By pushing the boundaries of what can be seen, the telescope gives us useful information about the technical difficulties of studying galaxies and other things in space that are far away. It shows how creative people can be and how hard scientists, engineers, and workers work together to plan, build, and run cutting-edge space observatories. Astronomers are looking forward to more discoveries from the JWST that will change the way we think about the world. In the future, scientists may find more early huge galaxies. This would help us learn more about the different kinds of structures in the universe and how they change over time. These findings will help us continue to try to figure out the mysteries of how the universe evolved, and they will also make us more interested in the complex dance of physical forces that shape the universe. Finally, the James Webb Space Telescope's finding of early massive galaxies is a big step forward in our study of how the universe began and how it has changed over time.